Howdy folks. Today we're going to talk about Git remotes. Git remotes are a really important part of Git that lets you store your code in another location, back it up, allow other people to work on it. So they're a really important thing, so I'm excited to talk about it. Let's get into it. What is a Git remote? So one of the major points of Git is to keep your code safe. If you have a Git repository on your laptop or on your desktop computer and you haven't set up a remote for it, your code is still just on that computer, which means that if something happens to that computer, or if you want to go work on another computer, then you can't really do that very easily. You have to manually copy that code over. Git remote is a remote server that is not your computer, where your code can be stored. This keeps it safe and also lets you download it again very easily onto other machines. It also helps share code among possibly your other teammates if you've got other people working on it. So you can see here we have our server there, that little oil barrel cylinder thing. That would be the Git remote, and all the little other computers that people are working on, they will get their data from it. Common providers include GitHub, which is one of the biggest ones, GitLab, which is slightly smaller, but also well known. Large companies may have their own Git remotes as well because they don't always trust these providers to hold on to their code. Sometimes your company may have something that looks like GitHub or GitLab because those two companies license their software out. So you can start up your own server and install the GitHub software on it and just run a remote repository system like that. You can also just run your own. You could use the GitHub or GitLab software, but you could also just install the Git server and run it. And that is totally fine. It's completely up to you if you want to do that. Let's take a look at some examples of how we would use this. So I'm going to go to GitHub, and presumably you've already got your SSH keys set up because we will be making use of that here. So what I'm going to do is, first of all, I'm going to create a new repository. And you probably won't need to choose owner. The only reason I need to do that is because I'm part of multiple organizations on GitHub, so I need to decide where this repository lives. So if I call it my repo, I'm going to make it private for now. And I'm going to initialize a README file. I'm going to start with some code already in it. Okay, create repository. And even if, so maybe you've got someone else's repository they've given to you, at this point the steps would be exactly the same. If I want to get this repository down onto my computer, I'm going to click code here, and in GitLab it's similar. And then I don't want the HTTPS. If you pick that, then you have to actually log in when you push with your GitHub username and password, which isn't great. I've already gone to the trouble of setting up the SSH key, so I'm going to pick SSH, click copy here, go to my terminal. I've already prepared a directory for this. Oops, you can see it is empty, so what I want to run is the git clone command. So there's git clone, and I'm going to paste that repository link that I copied. Run that. You see it takes a minute. The remote here shows that this is something that is happening on the remote server. It's giving me these logs, counting objects. This will take a longer time on bigger repositories. And what happens is Git creates a directory for you. So you see that is my repo directory. And if I go into it, there's my README. So if I wanted to change a file or push a file here, let's say I have index.html. If I run git status, it says that's an untracked file. So let's commit it. Index file. Now, you can see if I run git status, my branch is ahead of origin main by one commit. If there's something on origin main that someone else has committed, this would then tell me my branch is behind origin main by one commit. So what I'm going to do is I'm going to run git push. It says, okay, enumerating objects, counting objects, push them all up, wrote main to main. Now if I come back here and reload this, you can see there's my index.html. Very cool. And I can just keep doing that. And now someone else who runs git pull will get my changes. So let me show you how that works. I'm going to actually go up a directory again, and I'm going to rerun that git clone. So now I have two. I'm going to have this repository cloned twice. Okay, and let me make a new. I'll make a new tab for it. So this is the second one, and then I'm going to go back to my code repo, and let's add another file. We're going to add it. We're going to commit it, and then we'll push it. Okay. Now I have 3 files here. The remote has 3 files here. But if I go over to my second copy, I don't. If I take a look here, it'll still say I'm up to date until I run git fetch. And the reason is git is not constantly checking with the remote server because that could be kind of expensive. And it was built in a time when bandwidth was a little harder to get. So if I run git fetch though, it's going to get the updates. Okay. Now if I run ls here, I still don't have that file. But git status now tells me that my branch is behind by 1 commit. So in order to get it, I run git pull. It's a good idea whenever you start working on something to just run git pull, just to pull any changes from the remote, just in case. I can't tell you the number of times I've been bitten by that, where I wrote a bunch of changes, ran git pull after I wrote the changes, and then I ran into merge conflicts, which we'll talk about in a later video. I pull. It says, okay, look, added file 2. Now when I run that, they're both in there. So let's say I make another directory, cool code, and I run git init, which you can do. What is that going to do? That's going to create a local git repository. I don't have a remote for it though. So let's say I create my index. I see that, but you notice this doesn't have the origin on it. This doesn't say your branch main is tracking origin main. So what if we try to commit this? Commit index file. That's so far so good. Run status. But if I run git push, it says you don't have any remotes. Why don't we have any remotes? Well, when we cloned our repository, Git sets up a remote for us automatically. We can check that by running git remote-v. You can see it's created a remote called origin, and that's where that origin main comes from. Origin is this particular repository. The reason there's 2 of these is because you can have separate different URLs for pulling data as opposed to pushing data. I don't see this very commonly used, but Git is a very flexible system. Now if I come over here to our new repository, cool code, git remote-v, we don't have any remotes. Well, let's get one. So what I want to do, I'm going to come back here and I'm going to make another new repository. And I'm going to call this my repo 2. Okay, I'm also going to make it private. I'm not going to initialize with a README. If you initialize this with a README, you get disconnected histories, and Git gets very grumpy about that, and it makes you figure out what to do. So if you already have code on your local machine in a repository that you want to just push to a new remote, do not add a README file. If you're creating your remote and you plan to clone it and then add code, then you should add the README file. So I'm going to create that repository. And GitHub's smart enough to say, oh, this is empty, so you might want to do quick setup. It's very handy because this is the command that we run. Let's take a look at it. We'll put it in our terminal. Git remote add. So this is the command that we're actually doing. Origin. This is the name of the remote. So we saw over here, this remote was called origin. We don't have to call it origin. You can call it something else. But it's standard to call it origin, and this, because that's just the normal thing, I'm going to leave it as that. And then again, the URL for our remote. Run that. Nothing really changes. But if I run git remote-v again, you can see there's my origin. Okay, cool. Let's push again. Not so fast. Now we have an origin, but Git is saying, look, I know your local branch is called main. I'm not sure who you want that to be connected to in the remote. So that's why it's saying git push set upstream. So if we say git push, I'm going to put -u because -u is the shorthand for the set upstream here. The name of my remote, and then the name of the branch. This does not have to be the same as your local branch. My local branch is called main. I could name this something else on the remote. It's just a good practice to have them have the same name. So now I push that, and now you can see it says I created a new branch, and it's set up to track origin main. Now if I come here, reload, you can see there is my index.html. So in conclusion, a Git remote is used to keep your code safe and also to share it among even yourself if you have multiple computers you're working on or among other teammates. If you have a repository that already exists in a remote, you can use git clone with the SSH URL to bring it to your local machine. At that point, everything's already set up nicely and you can just push from there. If you have code on your local machine and you have created a Git repository, but you don't have a remote yet, you want to create an empty remote or an empty repository in your remote. Then you use git remote add to add that origin or to add that remote to your repository on your local machine. And then when you push, you want to attach the branch to a remote branch so it knows where to push to. I hope this is helpful, and I'll see you all next time.